Hi, Srikanth. Very warm welcome to NISC 2020. As an Executive Council member, it's a very warm welcome to you because you have supported this conference all through in all our discussions for last 2 years. Friends, it's my proud privilege to introduce you to Srikanth Velamakanni. He is the founder and the CEO of Fractal uh, Analytics, which has done wonders in the industry, as you already know. The reason why am I here is because I want to take half a minute to explain to you the value of having to have a person like Srikanth in the executive council of NASCOM who drives technology and the business vision together. And when I explained to him that we are running we are running a full-fledged conference for SMEs, and there are going to be almost 1,200 SMEs joining us for these 2 days. He showed tremendous interest in saying that he would like to show us the path as to how AI applications can be adopted by the SME companies for building their new business models or future business models, and especially those who are on the AI services. How can they probably create new IP using the new technologies available? So I thought it's extremely valuable that Srikanth addresses us today, and we use his know-how from not only the technology and business point of view, but also maybe a minute from Srikanth to understand how did Fractal grow with his leadership as a co-founder and so on and so forth. So thank you, Srikanth. Once again, a very, very warm welcome to you. And we really deeply appreciate the time you have given us. The session is all yours. And from now onwards, Justin will look after everything. And I also want to say one thing to the audience. Please see the Q&A button on the right side. Please use this button to constantly post your questions so that towards the end of Srikanth's session, we can take up your questions for answering. Also, those who once you finish this session, please do go to the exhibitors booth once again and see if you'd like to communicate with the exhibitors who are there. Great partners to have in your business. Thank you very much, everyone, and welcome, Srikanth.
Thank you, Hanuman. Thanks for this very warm welcome. And I'm going to just start by walking you through. Wait, okay. Right. Hi, everyone. Great to be here. As you've been hearing for a number of years, I think it started with Mark Andreessen saying that software is eating the world. And the last few years, it's become AI is eating software. The world is really changing. And just to give you a glimpse of whether AI is going to change the world, I want to tell you a little bit about this picture here. This was shot in 1900 on an Easter morning on Fifth Avenue. You can see a bunch of horse-drawn carts. This is 1900. And just a mere 13 years later, this was the picture. A full contrast, because from horse-drawn carriages, the whole world had changed to automobiles. In 13 short years, the world had completely changed, and people who had bet on the horse carriages business model and the industries that were supplying horses, they all, the population of horses declined for the next many years because of this massive change. So massive change can happen in very short periods of time, and if you're not ready for it, it can really hurt your business. It provides an opportunity, but equally a threat. And AI is now eating the software industry and AI and the tech services industry, and therefore you need to pay attention. I want to give you a little story about this Japanese farmer called Makoto Koike. He is an engineer, and 5 years back, he went back to his parents for a vacation, and he saw his mother sorting cucumbers. And he was very concerned because they produce this cucumber. They have a cucumber farm, and Japanese cucumbers come in 9 different varieties, and she was manually sorting them into those 9 different categories. And she couldn't use temporary labor, she couldn't use anything, so she was doing it manually. So he decided, AI is changing the world. Maybe I can use AI to do something. So he built a software system to enable her to sort cucumbers. And here's how the system looks. Right? You can see that on the left panel here, you can see that cucumbers are coming through the lot, and there's a camera that takes a picture of those cucumbers. Then a TensorFlow algorithm processes those pictures into and decides which category, 9 categories it belongs to. Then as it goes to the bins, there's a little nudge, a Raspberry Pi 3 based controller. It pushes these into the 9 different bins. And then this system keeps learning over time. So with 70% accuracy, with using just 5,000 images of cucumbers, he could create this system, right? And if he could use AI to change his mom's situation, AI can be used by anybody. But the reason I'm actually walking you through this example is because, in a way, this is the microcosm of what AI is trying to do, right? If you look at all AI problems, essentially they can be split into perception problems. Essentially, it's about taking in the environment. You saw as the cucumbers were coming, there's an image processing that is happening. So perception was happening. We are perceiving an image. Then we're processing that image to understand which categories it belongs to. Then we're acting and nudging the cucumbers into the right bins. So some decision making actions. And there's a learning system that's learning all the time. So these are essentially the four building blocks of any AI system. And what we are seeing is that in each of those four areas, AI is beginning to make tremendous progress. So if we look at perception, Fractal's Cure.ai has got FDA approval for FDA clearance for looking at a head CT scan and figuring out which abnormalities are happening in that head CT scan. So 4 different abnormalities, FDA has provided clearance to that. So perception, AI is beginning to match and exceed human capabilities. There are a number of other cases where image processing, video, you're seeing that AI is beginning to outperform human beings. And coming to processing, right? It seemed like a really hard problem, poker, right? I mean, people thought that humans will always be better than machines in poker. But Facebook's Pluribus AI, poker AI, actually has shown that it can beat human beings very, very well. So right now, there's no contest anymore. That even in a game that involves so much of chance, uncertainty, and things like decision making, understanding other people's expression, and actually being able to bluff, it's able to outperform human beings, right? Now that's on processing. Now coming to acting, this is by OpenAI created a system by which even a Rubik's cube can be manipulated. It's very difficult to, if you think about manual dexterity is very, very difficult for robots. But this system actually takes a Rubik's cube and actually assembles a Rubik's cube and sort of gets all colors. Just so the physical dexterity aspect of it, which has been a long elusive aspect of AI and robotics, is beginning to get better and starting to match humans. And even Boston Dynamics is doing a whole host of these wonderful demonstrations of how the technology can basically create humanoids that have movements very much like a human being, right? Even much better than human beings. So this is where AI is beginning to exceed human potential, even in perception, processing, acting, and even in learning. DeepMind built AlphaStar a couple of years ago, and to play the game of StarCraft 2. It's a very complicated game, lots of uncertainty, lots of information, asymmetric information, and you have to do a whole host of decisions. And certainly AI performed very well, but in this case, this AI learned this whole game just by playing itself. It just played millions of games with itself, and then got no human intervention. Humans didn't teach them anything. It just learned how to play the game, and now it can beat any human level player. So even in learning, AI is beginning to show a lot of potential. So my submission to you is that you cannot ignore AI anymore, and AI is beginning to take more and more play a more and more important role in our lives, and therefore in your industries, in the clients that you serve. If you look at the last 200 years, I mean, we had the industrial age, which was just about automated elevators, industrialization of factories. This is the first wave where, if you look at the mission complexity, what we are trying to solve, and the sense-making complexity on the y-axis, we were solving some low mission complexity and low sense-making problems. Then it became about the information revolution, which is about how do we bring in data to drive, how do we bring technology and data to drive basic automation and so on. And then we had better examples like Google and Amazon, recommendation systems, and the Google's AI really understanding not just what query you're giving, but really the intent behind your query, right? And then came a whole host of other applications like Cure or Maps or robotic pharmacies. These are trying to solve more and more complex problems where the data and the sense-making complexity of the various kinds of data sources that you have to process to come up with a decision are increasing. And that horizon is constantly moving forward. And now I think you're seeing that it is moving into this orange realm, which is the human realm. Ray Dalio with his with his hedge fund Bridgewater, is basically saying, can you automate all my decision making so that when I retire, a machine can take over and do my job, right? That's what he's attempting, not successfully, because these are still in the human realm. Self-driving cars, still in the human realm. AI is getting better and better. Maybe self-driving cars may be getting ready. But as you go from left to right, from the left hand to the top right hand corner, you see that the complexity and the cost also keep increasing. And therefore, when you are in the orange zone, the cost is just prohibitive right now. So you've seen failures like Watson and so on. But it doesn't mean that some of these in the light blue and the dark blue areas, they are completely within the realm of AI applications. And that's where AI is beginning to show a lot of success. Right? In the next few years, because of the success and because of huge advances in computational capability, reducing cost of storage, or it is about slightly better algorithms, you will see that cost of AI will keep coming down. And it will keep coming down very dramatically. It is actually following the Moore's law or even improving on Moore's law. And once that happens, AI will become more and more ubiquitous. Already, if you're using TikTok, if you were using TikTok, you will see that it's basically an AI system. The recommendations are so good that it just is addictive, right? So you will see AI in everything, though not overt, but in a covert manner, in a hidden way. You'll see that AI is beginning to play a role, and then every problem will start becoming an AI problem. And what I mean by that is, look at as things like imaging, right? I mean, we talked about Cure.ai as healthcare AI imaging. It was not a AI problem, but because AI has become so good, it starts to be reframed as an AI problem. So AI will change the world in a very, very meaningful way. Now, that if we agree on that, how can you use AI to grow your business? How can you use AI to grow your business? Because many of you provide some very interesting, important tech services to your clients. Can you bring in AI into that? So first thing I'll say is, I just have 3 points here. The first point here is that AI alone is not enough, right? And you're already providing some very solid engineering services, tech services to your clients. But if you can bring in AI and design, you can actually solve very big and complex problems, which can help you scale the kind of work that you do with your clients, right? And let me explain what this AI engineering design is all about and what Fractal believes in, right? So first, let me take the AI layer and explain it a little bit further. It's about smarter algorithms. I talked about Cure.ai. Let me give you another example of Cure.ai with this chest X-rays. As chest X-rays, today there are more than 1 billion chest X-rays that are read annually, right? And in that, there is a 20 to 23% error rate around the world, because doctors miss important findings. Radiologists miss important findings because they're not paying attention, or they have too insufficient time, and so on. 19% of lung nodules are missing, and some of them are actually are missed, which means that lung cancers are not detected. These are the kinds of challenges. So what Cure did is, how do we fit in with existing radiologists by creating an automated report based on an X-ray? So take an X-ray, build algorithms, and pick out now 29 different abnormalities, including COVID-19 as an abnormality, we can pick out from an X-ray. And this has become really handy. Hospitals in Italy, Mexico, UK, US, India have all used this system to find out COVID and other kinds of abnormalities, TB, for example, big problems in the world. But great algorithmic sophistication that is bringing in incredible amount of new accuracy, and it is working very well alongside with doctors. So we bring in the AI angle, the engineering angle, which is about making it all real time, and the design angle, which is about working with doctors in such a way that is seamlessly helping doctors rather than trying to replace doctors. So bringing AI, engineering, and design. So this is a great example of great AI, but also of great engineering and design. Now, let me dig a little deeper into an engineering problem. When COVID-19 hit, I got a call from the Municipal Commissioner of Mumbai saying, we need help. And the next few months, our team, along with NASCOM and along with Intel, AWS, we built these systems for Mumbai, for Karnataka, for Telangana, and so on. It started with looking at the problem as, how do we trace arrivals? How do we find out who are the people who have arrived into Mumbai? It then became, how do we look at predict upcoming hotspots, and what kind of decisions should we make to mitigate hotspots? Then it was about predicting healthcare capacity and managing healthcare capacity, healthcare workers, PPEs, and so on. And then it was about making sure that from the time somebody gets positive on COVID, we are able to put that person in a hospital or a quarantine center in the right one in less than 2 hours. And then it was about how do we unlock industries, and how do you see when you unlock an industrial zone, what would that impact be in terms of cases and so on? How do we safely unlock the country? The problem kept changing, but underlying there was a data engineering complexity. There were huge number of cases, huge number of data sources. As you know, India health systems are not really connected. Hospitals have never been connected with each other to find out healthcare capacity. All the testing data that was coming in was all in different places. So how do you put all of this data together so that decision makers have the right information at the right time to make decisions? And lots of algorithms, but the engineering complexity or the data engineering complexity was massive. So every big problem has a lot of engineering complexity, and some of you are providing great tech services to your clients, and therefore you already have one of the three ingredients, which is great engineering expertise, especially cloud engineering expertise, already in your system. How do you bring in AI expertise? And then the way to frame and solve problems, how do you bring in that expertise? Now, let me specifically talk about a third dimension, which is about design. Design is about framing and solving the right problems. How do we know what is the problem to solve? I'll give you one example of when we tried to solve a problem of medication adherence. A few years ago, one of our healthcare clients said, can you predict who's going to take my medication on time? Right? Because when people don't take medicines on time, they get worse. Like chronic disease like diabetes, etc., can be solved by just following a regimen of medication. But people don't. People are not very good at taking this disciplined use of medication. So they said, can you predict who's likely to take their drugs on time? And we did. And it was slightly better than a naive model which said people who don't take drugs on time will continue to be that way. People who are indisciplined will be indisciplined. People who are disciplined will stay disciplined. We could improve on that very naive logic a little bit using very sophisticated algorithms. But what we missed was a much bigger trend, which is that the real problem is not about predicting who's likely to take their drugs on time. The real problem is to improve medication adherence. So here comes a company called PillPack, bought by Amazon for $1 billion in 2019. And this company basically takes all your medication prescription data and really creates these beautiful packs, little packs with timestamps, etc. All you have to do is to peel open that pack and pop all the medicines, 15, 20, whatever number of medicines you take, it figures out yours and manufactures the specific, these little boxes for you with these little pill packs, and you can open a pill pack and take a medicine. So they did not take the problem as predicting medication adherence. They took the problem as improving medication adherence. So design is all about framing and reframing problems and including understanding human behavior and removing barriers to adoption. And so that's really what we ended up, PillPack ended up doing. So to summarize, what I'm saying is bring in not just your engineering capabilities, but design and AI capabilities, and you can solve much bigger and better problems. That's one way to scale and grow your business, because that's really where you can create much stronger impact for your clients. The second dimension I want to mention, in order to build this great capability around AI, to really leverage the opportunity of AI, is to look at your talent. And this is just across different kinds of American sports. You've looked at the average salaries of the players, right? You can see different salaries, but the top players get on the average 5 times the salary of the average players, 5 times the average salary of the average player, right? Just imagine, do you really pay your top talent 5 times your average player? Probably 30% more, maybe 50% more. But really, sports have shown that the top players are worth 5 times the average player. And I can tell you that in a disruptively evolving field like AI or tech engineering or cloud engineering, game-changing talent is 5x or 10x as valuable as the average player. Are you really able to attract that talent and pay them appropriately? If you look at Fractal, like, we had to raise the bar for talent. And my suggestion is look at your talent and see if you can raise the bar. For Fractal, in the last 12 months, this is from 2019 to 2020, we had 140,000 resumes, of which we only hired 0.53%, under 1% of people of the resumes that we received, right? Very thorough, very high bar. And that even at that level, we can get some really good talent, which can be game changing. So if you're looking at your talent, see if you can bring in game changing talent and see if you can create that environment for them and see if you can pay them appropriately, because that's the only way you can attract and retain that kind of talent. Right? And now that's my second point. And the third point is about innovation. How do you bring in breakthrough innovation? Innovation is nothing but creating a new recipe with the same ingredients. You already have the recipe, you already have the ingredients. And AI engineering and design, if you can bring that, and how do you create innovation with that, is about changing your org structure, looking at your org structure. Look, you're all very successful organizations, successful for a reason, right? You've got good talent, you tapped into a market opportunity, you built a great organization culture and built success so far. But now that's own success could be the biggest enemy for future success. And success creates that kind of complacency and could also create barriers to future adoption, because every time you try something new and different, it's not big enough. And existing antibodies in the organization are going to say, no, this is not working. Let's drop this idea. So there's a lot of resistance to innovation. So one of the things that Professor Luke Williams of New York University talks about is how do we do disruptive innovation? There is a core that you already have, which is about continuity, which is successful, and really you don't want to disrupt that successful engine that you've already built. But can you build an engine on the side which is for disruptive innovation, a discontinuous innovation? And for that, can you look at a new market, a new set of customer, a new product, a new process? Can you look at something that can and build it out while you're continuing to build the existing business model? I'll give you a Netflix example. I used to live in the US back in the day when Netflix was sending DVDs by mail. And it was a great business model. And I was really maxing out on usage of Netflix using those DVDs. And then when they launched the streaming business, I was very surprised because it took significant investments from Netflix to launch that DVD, the streaming business. And it was going to directly challenge its existing DVD by mail business. And they were already beating Blockbuster quite handily using the DVDs by mail business, and there was no competition. You could have said, why are they investing so much money? But they invested hundreds of millions of dollars in building those data pipelines, in building those streaming pipelines. And then soon enough, in 2007, by 2008, 25% of US bandwidth was actually Netflix bandwidth, right? Everything changed. If they had not invested hundreds of millions of dollars in creating that streaming capacity, Hulu or somebody else would have come in and completely disrupted their business. By creating this engine outside the core and then disrupting the core at the right appropriate time, they managed to win. Right? How is Fractal doing it? Fractal has grown quite nicely in the last few years. And one of the things that we have done very well is actually disrupting the core by actually creating businesses like Cure.ai. Cure.ai was set up completely separately, and it has really scaled up nicely because we've brought in very, very sharp talent and given them a lot of freedom and created that. Similarly, we've built Cuddle.ai, which is about empowering business information to business users in where AI meets BI. Again, created a separate team and funded them and created that business. And similarly, we have been building lots of these ancillary businesses which are adjacent to the core and are disrupting and really bringing disruptive thinking to the picture. And that's helping us in certainly scaling those businesses, but also has a shadow effect on the core business, which is actually expanding quite rapidly. So that's all I wanted to share with you guys. I hope you have a little bit of a sense for where I'm going with this, and look forward to your questions. I know you're building a great business right now. My question is, if you're not incorporating AI, how can you scale it? So please consider bringing AI services into your own mix and therefore scale your businesses. Thank you.